Nice little parametric problem right here. We know the order goes position, velocity, acceleration. It gives us the dxdt, that's the x prime. So that's the velocity with the x's. And it also gives us the original function for y. So I took the derivative of that, and that became my y prime, which is the dy dt. So there's the velocity vector. It's asking for the acceleration vector at t equals 1. So if you have the velocity function, then we could just use the math 8 feature, where it'll take the derivative for us at that particular point. So try that on your own in the calculator. Use the math 8 feature and make sure you can get those numbers there. Go 3 numbers after the decimal for the acceleration vector. Second part, in between 0 and pi, find the speed at which, it says find the first time at which the speed of the particle is 1.5. So I'm going to first start with my speed formula, which is the square root of dx dt squared plus dy dt squared, and set that equal to 1.5. So what I did is, there's my dx dt, there's my dy dt. So I have to solve this crazy looking equation. So anytime I have a harder looking equation solve, I want to minus the 1.5 over, I'm going to get everything on one side, set it equal to 0. So I'm going to I graph this in the graphing calculator in between 0 and 2 pi. So I hit my window button, I made my x min 0, my x max pi, and then I let it calculate the zeros for me. There's 2 spots where it was equal to 0, but if you read the problem, it says find where it's first equal to 0. So I just needed to find that very first number that t equals 1.254. So make sure you know where this is coming from. Make sure you practice that on your own in the graphing calculator and let it calculate that 0 for you. Let me know if you have any additional questions. Part C says find the slope. So on a parametric problem, when I see that word slope, I know that's dy dx, which is dy dt over dx dt. The dy dt is what we found on our own. The dx dt was given to us, and it says find the slope at t equals 1. So once I get that, that's my dy dx. Plug in 1 for the t, and then this is a calculator problem, so you can get that decimal answer. Also, we're not done with that one. It also asks us to find the x coordinate of the position particle. So if they give you the dxet, that's like the velocity, and now they need to integrate that to find the position. But anytime you find a position, you got to always take into account the initial position. So if I want to find the x coordinate position at t equals 1, that means I want to find x of 1. Now, since they gave us at t equals 0, this is where we're at. At t equals 0, that's where my x coordinate was. So I'm going to do at x of 0, since that's what we are given, that's the initial starting value. And then so I pick it up where I left off at 0. I integrate it from 0 to where I want to go, that 1. So there's your initial position, and then you're integrating how far you went. So when you integrate that dxt between 0 and 1, you're going to integrate this function, math 9 that thing in between 0 and 1. It tells you how far you went, take into account your initial position to get that 3.342 number. Last part is the total distance traveled. So that's just the integral of your speed formula, which is all in your blue packet. So there's your speed formula. And then we're going to do the integral of the speed formula in between 0 and pi. So in the calculator, this is what I'm entering in right here. So I usually just try to write that down and enter that stuff into the calculator. Math 9 that thing, please practice that on your own. Make sure you can get that and get comfortable with that and get quick with the calculator type of stuff. Snickers.